I think one of the reasons we're hearing so much about big data is we're sort of in a positive feedback loop on this, by which I mean there's media press about big data, which gets people interested in big data, which creates more media press about big data, and so we're in this spiral. But there are a couple other things. One is technology has enabled us to have much more data than we ever had before. So you may not realize this, but we all walk around with sensor devices. What we think of as our iPhone or our Google phone is actually a sensor device. It captures all sorts of telemetry information, which is then shipped back to the mothership where it's analyzed. And people are beginning to see the value of this big data, and organizations, especially in the federal government, are being able to see the value of this big data more and more. So, for example, the ability to take all the medical patient data that we can get from lab tests, from constant monitoring of patients while they're in hospitals, by looking at the complete medical record, builds a huge amount of data that needs to be analyzed. And frankly, the challenges are not in the acquisition, I don't think, and the storage of the data. I think we've got a handle on those. But the ability to do analytics on this data to extract some value out of it. So I think increasingly we're going to hear more about it. I think we're also going to hear about privacy concerns with big data, especially our medical data, and what the phone companies are doing with the location data that we have. I read an interesting article just this week where by knowing your location, measured by either 5 or 7 spots in a city, they can identify you with 95% probability because of people's repeatable analytic patterns. So we hear a lot about big data because there is a lot of big data and there's a lot of value to be had out of big data. One of the things I would like my phone to do is tell me where the cheapest gas station is when I'm driving someplace and my meter gets down below a quarter of a tank. I'd like that. I'd like to know other things as well when I travel, like what routes are congested now. And around Washington, D.C., that's an important thing to know, especially as you try and cross the American Legion Bridge at 5:30 someday. So there's all kinds of reasons, I think, why this is an important topic these days. Greenplum, company I work for, which has now become another company called Pivotal, began basically as a big data analytics company. And our strength was in the ability to provide analysis of large data sets in a cost-efficient manner, in a way that did not put a huge strain on other IT resources, but with the use of fairly sophisticated analytic techniques, some of which we built into the database, some of which we use with partners. Since then, we've gone on into analyzing data sets that don't traditionally fit into structured databases, but live in the Hadoop world of semi-structured and unstructured data. And recently we announced that we could now use standard relational database technology on top of general unstructured data in Hadoop, a major breakthrough. The other thing we've done in forming this new company called Pivotal is to actually blend in agile rapid application development into the platform, which I think is one of the problems now, is that we have data, we have tools to analyze big data, but we don't have the marriage of that technology with the rapid application development technology, and then the means to deploy this in the cloud, in a cloud-independent manner, platform-independent manner. Those are what I think we at Pivotal provide to our federal customers. The first piece of advice I give them is they're going to have to train staff, because working in big data is different than working in traditional IT realms. The tools that we use and have used successfully for the last 10, 15, 20 years are not the tools that we want to use in the next 10 to 15 years. We want to be able to do more things that are predictive of the future rather than analytic of the past. I think that talent is lacking everywhere, not the federal government, the private sector, everywhere. And I think it's important that we sort of have to train up the current staff in the federal government to be aware of these techniques and look for people who can actually use these techniques. It requires some amount of sophistication in mathematics, in computer science, in general analytics, and it's not the same kind of technique that we've been using for the last 10 years in what we call business intelligence. We've mastered that, but that's got its limitations, and we need to focus on the training of people we call data scientists these days. First of all, there are things I can't share, but the intelligence community, for example, have been using big data before big data was cool. And they're quite good at doing whatever it is they do. But outside of that, we see applications. I read a really interesting one just this week, which was someplace in Africa, I can't remember which country. The transportation authorities got a lot of anonymized cell phone data of where people were, who they were calling, and from how those mapped to cell phone towers in order to optimize the public transportation system. And so they realized that they could realize what the flow of people was over time and how they should reroute the buses so that they took advantage of where people were and where people wanted to go, rather than where people were and people wanted to go 5 years ago when they last, redid the bus routes. That's, to my mind, a really interesting example of big data use. But in our own federal government, certainly people are using big data analytic techniques in the economic sector. And they've been doing this more or less for years, but I think they're becoming more savvy and more sophisticated, looking at larger data sets with greater amount of detail. Fraud, waste, and abuse. Shockingly, there's a lot of money that's spent by the federal government, and people would like to take advantage of that and grab some illegally. Center for Medicare and Medicaid Studies uses big data analytic techniques to discover what they believe to be fraudulent Medicare claims. The Internal Revenue Service, you'll be shocked to know, has people who try to cheat it and get returns when they are not entitled to returns. And they're using similar techniques to do this. Let's see if I can think of a few more examples. Certainly in the cyber analytics field, there are people who want to break into Department of Defense, Department of Energy lab sites, and these folks are fairly subtle. And they're always one step ahead of what the current technology is. So the goal is to use big data analytics techniques that look at attacks on cyber facilities over time, so that you need to store huge amounts of data, because a careful cyber attack might do something like try one site now, wait 32 days, try another site, because the normal flush time is 30 days. So being able to keep that kind of large amounts of data is certainly a big win, and being able to analyze and look for patterns that, not just at my site, but at all the coordinated sites in my environment, a very big use case. Things of that nature. I think the next challenges in the field are, one, getting big data out to beyond the community that sees it now. So the community that sees it now basically are lines of business people in the federal government as viewed through what they can get from their data scientists and their analytics community. But we really haven't propagated that to the end users. By the end users, I mean the general American public, nearly as much as we can through, say, mobile device technology. So making what sometimes are called consumer grade big data analytics, I think, is the next challenge. We at Pivotal are focused on this challenge. We're not there yet. We're starting this journey, but we hope to have a platform out, and we should by the end of this year, where we're going to integrate big data analytics, rapid application development, as well as cloud-based deployment strategies. So people can quickly figure out things that they need to from federal government data. For example, I live now near, say, 4 very good, competent hospitals. Saturday morning, I'm cutting bagels. I accidentally slice my thumb. Which emergency room should I go to? It would be really nice to have an app or something like that that sort of integrated this kind of information and said the waiting time at hospital A is 5 minutes, at B it's 15 minutes, et cetera. And I can sort of decide then where it's useful to go if I'm bleeding and needed to be stitched up. Certainly that percolates up to the EMT people, who have to figure this out. And I think there are apps that already do this for them. But that's the kind of thing of making this information generally available. What's the best time to call up the IRS field office to get information about Form 2337 or whatever it is, which is completely unintelligible to me? Things like that, I think, could be really incredibly helpful. And I think that mass deployment of big data analytics is the next frontier.